Engineering here in Seattle at the University of Washington. Yeah, I see David's here. Um, the question about his experience with assessment of data science courses and programs. So what I'm going to talk to you all about today is the design of a new course. It's about 2 years old at this point that I was hired to create here at the University of Washington um, called Intermediate Data Programming. And I'll explain a little bit what we mean by that. And a huge part of what I've been trying to do here is trying to figure out how do you um, give students meaningful open-ended projects to work on things that they're interested in, that really motivates them, but in a way that somehow make sure that they meet learning objectives. And how do you frame that to students in ways that they can understand? And I'll talk a little bit about kind of one idea we had, which is this notion of challenge goals, of giving them explicit ways of spelling out ways that they can challenge themselves and working on that. So I'm going to go ahead and share my screen. I have some slides that I tried to get down into about 10 minutes, and I'll try my best. But I want to give you a little bit of a lay of the land of kind of what we're doing here and what this course is. I don't have a bunch of oh, my camera went all the way over there. There we go. Can you all see my slides all right? Great, thank you. I don't have a bunch of numbers for you today. This is more of an experience report, but hopefully you can see some things that that we tried here that you might find interesting, and definitely feel free to use any of this as inspiration. I want to give a shout out to my partner who actually drew this intro slide for me. That was a very nice looking thing that actually kind of covers everything that we do in this course. So before I explain what's the course, I got to give a little bit of context of where it fits in. So before I got to the University of Washington, we had a main intro programming series, CSE 142 and 143. These are large intro programming courses in Java, and they used to serve as kind of one of the main routes that students learn programming at the University of Washington. This is great for CS majors, but a little less great for everyone else on campus because a lot of need right now is in processing data for research. So about 10 years ago, we created a CS1 course in Python CSE 160. And this is a much smaller course. It's usually taken by grad students, but intro programming. But we found it limiting because it's a CS1 course. They're learning for loops and functions, and it's really hard to get very far when you are teaching them everything from scratch. And so this is kind of where I came in, is trying to create a course that follows on this, that gets to go a little bit more advanced into data analysis, but really focusing on the programming perspective. And so this is where, oh, whoops, this is where CSE 163 came from. But what? They're good. Sorry, my scrolling didn't work quite right. Importantly, though, a lot of students end up taking our first CSE 142 in Java because it's the main programming course. So we didn't want students to be siloed off. And so actually one of the really interesting things about this course is that anyone can take it as long as they have some prior programming experience. So if the big challenge for us at the beginning of the quarter is we have students coming in from Java and we need to teach them Python very, very quickly. And we tell them, you're great at programming, you just know different words. And we're just going to learn different words now, and then we'll go into all of this more advanced data analysis stuff. And this course has been rapidly expanding. Our first offering was 2 years ago. I was teaching about 90 students. And this year I'm teaching about 300 students a quarter. So we're kind of rapidly growing this course, and we want to grow it more. I'm not going to talk too much today about broader data science education at the University of Washington. Actually, my colleague Ben Marwick will be here next month talking to you about one of our new data science minors. But this is one course that is a really core part of that minor in terms of the programming aspect. So I talked about the context. What is this class? I kind of describe CSE 163 as 4 key learning competencies or high-level learning objectives. We want to do more advanced programming concepts. Because it's a CS2-like course, it's not just learning for loops or learning functions. We're doing more advanced programs, writing things that maybe take more than 100 lines of code, maybe working with classes and objects. Our second is working with types of data. So almost all of the programming concepts we introduce are tied into working with real data, namely tabular data like Excel or CSV, unstructured text data, working with images or geospatial data. So we have a bunch of case studies on different data types and how to process them. We also want to introduce students to modern data science tools and libraries. So throughout, we're also teaching them how do you process this data efficiently without having to write all this code from scratch. So using things like pandas or scikit-learn or NumPy for processing. And then also, because we're a computer science course, we try to teach some intro computer science concepts, namely efficiency, talking about how to use data structures, and talking about a bit about memory management in a computer. So that is at a very high level what we cover, but there's a much more detailed view that I'm not going to go through every single bullet point here. But in each of these core areas, we have many modules on various topics. So the more advanced programming, we do testing code, working with data structures, classes, and objects. When we, I want to make sure I open the chat in case I see any question. Oh, sorry, over here on the EtherDoc, sorry. I'm so used to teaching where I have to look at chat at the same time. Working with different data types, I mentioned we do tabular. We also work with time series, unstructured text, geospatial data, and images. In terms of data science tools and libraries, we teach them Jupyter notebooks. We also teach them how to write Python scripts and Visual Studio Code and how to install Python with Anaconda. We teach a lot of libraries for data science that are very, very popular. And then in terms of kind of computer science topics, we talk about efficiency, computer memory. We talk about some of the computing ideas behind how to make things efficient, like hashing and indices. And we also talk a little bit about why Python is generally a slow language and why that's okay for data scientists, why it's very powerful despite it being slow, because that's something that usually freaks students out. So that's kind of what the course is about. I want to talk a little bit about, one other thing I forgot. All of these things are programming concepts, but importantly, they're all grounded in data science applications. So when I said this course is a data programming course, I would say that it's maybe not a data science course per se, because we're not really teaching an analytical skills. We're teaching the programming skills that are required to do any analysis. Now, we do teach some analytical skills. We do focus all our applications on processing and analyzing data, but we're not doing things like statistical validity or things like that, because it's not a statistics course, it's a programming course, and those things are crucially important, but we're not the only class they're going to be taking related to data science. So we talk about principles of visualization, talking about what machine learning is at a high level, very importantly, talking about ethics and societal impact of data science whenever we learn something new. And we talk about things like joining data from multiple sources. So that's kind of what the course covers at a very high level. Let me talk a little bit about what we do in the course. So one thing I found very effective when teaching this course is running it as a flipped classroom. So what that means is students do all the preparation outside of class where they read and read or watch videos. Students have reported that sometimes they don't like reading. So I recorded videos of myself talking over the reading essentially, so they can have a mixed modality of what's going of the content. And their deliverable is each day they have a set of practice problems that are usually coding problems, but sometimes quiz questions, and they're due by the end of the day. And what we encourage students to do is do the readings or watch the videos beforehand, and then come to class and work with their peers on those practice problems. And then TAs and I walk around the Zoom room. Most of our offerings have unfortunately been on Zoom at this point, just with the length of the pandemic. But we walk around the Zoom room and we help them with these problems and give them more individualized help. And I think this has been really helpful because I believe that data science is best learned through experience. And I think that this flipped classroom model really helps us. I have a picture of the learning tool that we use called EdStem. This tool has been fantastic in transforming my course. It lets us host Python environments for students so they don't have to install anything on day one. We teach them installation later, but it's a really nice warm-up. It lets them interact with code and let us write auto-graded tests. So this EdStem thing has been absolutely fantastic for me in this course. That's what they're doing in class. We also have some assessments of kind of their learning each week. So we have programming assignments. I wanted to just highlight a couple fun programming assignments we use. So we have them write programs, then we assess them on their behavior and their code quality. Do they follow kind of style principles of writing good behaving code? We have them write a search engine. So taking unstructured text data, talking about TF IDF scores and trying to rank search results. So actually, this is actually the most complicated assignment in terms of just raw programming, but we do tie it into working with text. We have them analyze food access data. This is one of my favorite assignments because it actually has them work with two data sets, the census data and a food access data set, and join them together. And then you get to have a bunch of real world discussions about the census data and the food access data don't look very pretty. They're very complicated data sets, and trying to learn about where you read documentation and what data it chooses to exclude and include is part of this conversation. And we also get them working with images, doing things like template matching. If you have a small crop of an image, trying to find where it belongs in a larger image. So just trying to show them various things they can do. And throughout, we say these are obviously not the only things you can do with data programming. They're just the things we do these weeks to assess how far you're going. But ultimately, our final goal is a final project, which is work on a data analysis of their choosing, what they find authentic for themselves. And basically the only requirement is that it has to be using Python in a meaningful way, because it is a Python programming course. We give them a heuristic that it should be at least 120 lines, but that is not a hard limit. It's just whatever seems challenging enough. And I previewed it at the beginning. One of the things that we've been pioneering for the past year now is this notion of what makes a project challenging enough, which is identifying challenge goals. So we tell them, here are a couple ways that a project can be challenging. You could work with multiple data sets. You can work with really messy data. A lot of students try to do web scraping, and that is just really gross code to write usually. And I want to reward them for if they don't have the most stellar analysis, but they did a really cool data processing task. That's still important. They can go into applying statistical validity or other advanced data science topics that we just don't get time to talk about. We can talk about more advanced ways of training ML models or learning a new library. And importantly, we want to give students the opportunity to express themselves in their own way. And so we always have the chance to say, define your own challenge goal. We will work with you and make sure that that feels like the right level. But do feel free to challenge yourself in a different way. We think this is a relatively diverse set of ways that you can have a challenging project, but it's not the only way. And that's kind of the course so far. So kind of last slide I have is, and I haven't been watching the time, so hopefully I'm not going over, is kind of what challenges have I ran into while designing this course and where do I see it going in the future? So far, the biggest challenge for me, or the thing I've been thinking about a lot, is better integration of ethics and societal impacts of data science throughout the course. So far, they're kind of segregated into 2 days, which is better than nothing, but I wish we had a way of approaching these throughout the course. The challenge for me is how do you make time to bring it up in an in-depth way while still covering the things that you need? So that's a challenge. I don't know what the answer is, but I want us to keep working on that. So it's currently constrained just a couple lectures. We want to continue to scale our course. Ben next month is going to be talking about kind of our data science minor. And we need this course to be larger to serve more students, because this is one of the main programming courses that they might take for a data science minor. And so the current bottleneck is TA workload, because grading this final project is actually not just grading at the end, they're actually mentors for the project for about a month. And so TAs are really constrained on how many projects they can provide mentorship for. We also want to experiment with new methods for assessment to make more equitable and more effective assessments. So right now, we're currently working in what we call mastery-based grading, which is we dropped points and we grade everything on a ESNU scale: exemplary, satisfactory, not yet, and unaccessible. And we give students the option to resubmit. And so it's really more focused on feedback rather than points. I can't tell you how that's going right now. We're still in the process of trying it out. And then we want more classes for students to take after 163. And this is one of the big things. We're trying to expand our offerings of data science courses. And lastly, and finally, one that I'm most excited about is we're actually launching 163 in the high school. So next year, we're going to be teaching students in greater Seattle area high schools after their APCS, which is our intro Java equivalent, how to do this in the high school. And so there's lots of challenges to come through there, namely technology, because not every student has access to a computer that can run Python. So we really need to figure out a story here on how to do this. And I'm really excited to be working on that this year. That is all I have for you today. We're going to do questions after, I believe, more questions. I'm not quite sure the structure, but you're also always welcome to reach out to me and if you want to talk more about this. Thank you so much.
Thank you so much, Hunter. Now, this is a really interesting way and structure for the course. There are a couple questions that are already in the chat. Yeah, congrats about the TA load for the course.
Yeah, so I've been very thankful that my department's been able to actually give me 2 TAs so we usually have quiz sections at
Mhm.
UW, and we usually have one TA per section. I've actually, because it's a new course, gone in two TAs per section. So it's about a ratio of 15 students to one TA. We use undergrad TAs quite a lot at UW. So once a student has taken the course, they're eligible to TA it. So lots of challenges in trying to train undergrads in teaching. But
Mhm.
yeah, so that's kind of, we usually have we tell the TAs they're working about 15 hours a week, which is both involved with teaching and grading.
Gotcha. Um, and then on the mastery with resubmit, especially for large classes, it's awesome for learning, but we'll just multiply the grading by the
Yeah,
TA bottleneck because
yeah,
they get a lot of resubmissions.
yes,
So is that the case?
yes. That's a great question. That was my absolute biggest nightmare with this kind of system. Is it's just going to make us work more. One thing that makes it a lot easier is without points, you never have to worry about the difference between a 39 and a 40. You know how much time you and mental energy you waste just like, oh, is this fair to take off because they might not have known that yet. In some sense, you can always bias to be a little stricter or have higher standards because students have the option to resubmit. So as long as it's not the end of the world if you give them an S instead of an E, because they can resubmit it after a future week after responding to feedback. And I was really worried about the resubmission workload, but it turns out it only takes you about less than 5 minutes a student because the changes, the delta tends to be small. You go look at your past feedback and just say, oh yeah, they responded to it. That's great. And so far, we're like on 3 weeks of resubmissions. TAs have not told me anything about workload. They actually said it decreased a bit because that ESNU grading in the first place is just easier.
Nice.
And that and then there's a question about prereqs.
Mhm.
Yeah, it's just some programming course. It can either be intro Java or intro Python. So yeah, that's our big challenge is working with students with very diverse backgrounds in terms of programming. Uh, and
And
we kind
is
of
it
have like
any
a Python boot camp.
programming? So if they just come in with other programming, like C++ plus plus or other anything, you can retrain?
Yeah, we tell them that we have a little less support for them. Most of my materials, because I failed to mention because of this like many paths. If you go look back at this oh animations, if you go look back at this diagram I had, and you look at the scale of the intro Python course, it's like 300 students compared to the 4,000 students ish that are taking either 142 or 143. So they're just, I have like 90% of my students in 163 are from the Java background. And so most of my materials are constantly reference Java, like, oh, you already know this idea in Java. This is just slightly different words in Python. And I just don't have analogs for them for C++ because I just haven't made materials for C++. But
Mhm.
they're welcome to take the course. We just generally say you might need a little bit more support.
I guess we have one last question or two more, and then I think we'll do the next speaker. But you're saying you have unlimited resubmissions that people can do?
Uh, Great question. No, so to manage TA workload, they can make one resubmission a week on any assignment. So they can either submit homework 0 from a little while ago, or they can submit the most recent homework again. One of the challenges that we're running into actually is that a lot of students seem to, we tell them they can resubmit any work as long as it's had feedback on it and they made an initial submission by the deadline. So
Mhm.
one of the challenges we're running into is it seems like students are kind of putting off the work. They submit basically nothing for the first submission, and then they're now falling a bit behind. This is a little bit higher than we had before, and we're trying to think about how to better support students and make sure that because it's going to get pretty bad in a couple weeks once we start getting to this final project and they're 4 homework assignments behind.
Yeah. Okay, so I think we have one more, and Kendra pointed out as well. If you don't get asked, if you don't get to ask your question, or you think of one later, put it in the Etherpad. So Hunter, if you see questions underneath, like where we took notes, you can also add in things that we left out in the note taking. This is just our attempt to capture here some of the things you talked about. We'll also have this recording, but you can respond directly to people in the notes, and we'll try to put your or even put your contacts. So I think it's already in there for people to reach out. Okay, so last question, I think Andrew, you said, do you use GitHub or some other version control system for homework submissions?
Yeah, so we don't use GitHub. I think that it's a fantastic tool. It's just a little hard for students, mostly in their freshman year. So this EdSTEM system we use actually does kind of a diffing between previous assessments for you without students needing to use Git. I've used Git in other courses, some slightly more advanced courses, but this one, there's already so many technologies going on. I'm just a little hesitant to add just one more, which is Git, even though it's a very important and useful tool.
Mm. I have one question. The EdSTEM, is that a university license or is that something you got specifically for this course?
It started with just something I got for this course, and we're kind of actually growing it to be something more, at least in the Allen School or our computer science department. Most courses are using it for the discussion board aspect, but some of us are using it for more complicated, like the whole programming thing. But yeah, something that's still kind of in development.
Yeah, very interesting. Thank you. Thank you,
You're
Hunter.
welcome. Thanks for having me.
Great course. So we'll switch over. Please put your comments, and if you have experience with courses in this area or suggestions, also that too. We want to go around for like some of the challenges that Hunter mentioned. If you have experience with that, putting it in the Etherpad as well.